Welcome, class. Let's go over the announcements first. As usual, you see the video link for the lecture now. You also see the Google Meet session link. And this Saturday, the due assignments are quiz 7 to 9. So there's no PA due this week. But be careful, PA3 will be doing next week. And PA3 is the first assignment. You need to write a socket program using Golang. So it might take you some time. So you might want to start early. The testing server is already up and running. So if you want to start, you're free to go ahead. So that's about PA3. Now, the topics today. Oh, hi. Good afternoon, everyone. What do you have for lunch? Tell me. Okay. And let me come back to the topics today. So last week, we ended up saying that when we are designing a network application, there are 4 major design components. And we talk about the first design component is to decide what the architectures we use to model the application. There could be client-server, or the peer-to-peer architecture, or the hybrid of the two. Today we'll talk about the rest of the design components. Okay, there are 3 more. The second one is called process communication. For that, we use socket. To implement a network application, it's equivalent of allowing process-to-process communication. Okay, so in client-server's case, a client process communicating with the server process. In the P2P case, peer-peer processes communicating with each other. Now, take note, the server process, remember server is the one that's always on, right? So server process is always started early, since the beginning of the service. Only when the service is started, then you call that the service is available. Okay? And it's always there waiting to be contacted. The client process is the one after being started by the user, initiating communication to the server and getting something back from the server in return. Now in P2P paradigm, the exchange between the peer processes are then a little bit complex. Each peer process will have the client side and the server side implemented. Okay. The difference is that this peer process client side contacts the server side of the other peer, and vice versa. But either case, process-to-process communication. This is how you enable network applications. Now, let's take a step back and review. What is a process? It's a program running on a machine. So in fact, for 2 processes on the machine, there are occasionally the need to communicate with each other. Okay, this is possible and enabled by this set of API called Inter-Process Communication API. This is defined by every operating systems today, and this should be covered in the operating system course. Now, in case you don't have this, you might want to look it up a little bit, IPC. Now, in this course, we talk about process communicating with another process that are on different hosts. So 2 processes exchanging messages on different machines. How do we do this? We do have another set of APIs defined called the socket API that allow us to do this. If you call the socket API, a socket is created and associated to a process. And that's when the process can begin sending, receiving messages through the internet. Now, think of a socket as if there's a door. On one end of the door, the sending process pushes messages out. The other end of the door, we have the transport infrastructure. So let me explain with the picture here. Sending process here. Sending process pushes the message down, reaching the transport infrastructure. So the infrastructure here will move the packet further through the internet and come to the receiving end of the infrastructure. From here, messages go through the receiving socket and reaching the receiving process. And you see, process-to-process communication enabled by the socket API. Now, let me draw your attention here. From this line and above, this is application layer. Everything running here needs to be controlled and defined by the application developer, application designer. So it includes the functionality of the sending receiving processes as well as the kind of socket we want here and here. Hey, why is it challenging? Because the transport infrastructure, there are actually multiple type of services being provided. So in order to call the socket API creating a socket, one need to know which transport protocol to choose. This depends very much on the kind of applications you're designing. You might also define additional parameters so that a process is correctly associated with the socket. One very important parameter to define before creating a socket is called the port number. So the port number, you can think of it as a unique identifier for a process running on a machine. So keep this in mind. And now let's take one step back and think about why we need a port number. All right? So let's see how we uniquely identify a process running on the internet. Well, first is, of course, try to find the machine the process is running on first. How do we identify a machine on the internet? Yeah, we do have IP address. You guys should all have heard about IP address. It's a 32-bit long number. With this IP address, we identify a machine. But the question here is, does the IP address allow us to identify a process running on the machine? Having just the IP address, is it sufficient already? I know what you're thinking. You're probably thinking, no, not quite. If there are multiple processes running on the machine, then you cannot see exactly which process, right, we're looking for with just the IP address. Therefore, in order to identify uniquely a process running on a machine, we need something extra, the port number. So for a process running on the internet, in order to uniquely identify it, we need the IP address plus the port number. Okay. So a few example port numbers. For example, HTTP server, this is to support World Wide Web. It typically runs on port 80. So the socket connecting to HTTP server is on port 80. For mail server, port 25. It's a very common practice on the internet. For these very well-known services, we use a fixed port number so that it's easier for the programmers to remember. So that is also saying to send a web request, which is a HTTP request, to a server, gaia.cs.umass.edu. We send that message to here, or that socket is defined by this IP address and this port number. So this is the IP address of the web server, and this is the port number of the server process running there. All right. Okay, so that takes us also to the Q&A here. So Boris was asking, when you guys were doing PA1, right, you log into the PA server. When you're doing that, there's no port number specifying. So how do you reach the SSH server? And for SSH, there's also a default port number. So that way, the client program doesn't need to, you don't have to specify a port number. The client program will, by default, reach out to the default number. Okay. Now, the third design component. So once we have the architecture defined, we have the processes, we send messages between them, right? Defining the message format is also important. Now we have socket created connecting processes, we can begin to send messages. But you see, what we're talking about here is general application design. So an application can be a little bit complicated. The server could be providing multiple services. So how do we know, right? When the server receiving a message, the client is asking for service 1 or service 2 or service K. And vice versa. The server could be sending a message back to the client. And how does the client know what is the intention of the server? The messages being exchanged between these two processes need to be clearly defined. So that includes the type of messages. So one may be sending a message for a certain occasion. So there could be multiple types of messages defined for an application. Now use World Wide Web as an example. The client typically sends web requests and the server sends web response. And inside the response that contain the web page the client is asking for. Now, continue to use the World Wide Web as example. Inside a web request, there will be some fields, okay, we define. For example, time of the request, browser of the request, or language preferred by the user sending the request. Okay, so there'll be fields like this with the values. That will contain in the web request arriving at the server. Server knowing the syntax, okay, of the request message will understand exactly what's going on the client side, and therefore send the most up-to-date web page in the preferred language, for example. Now, we also define semantics of messages because, again, using World Wide Web as example, the web response a lot of times sends back, for example, status. Okay, so this is the status of the request. Now, if the client is looking for an object that's no longer existing on the server, you see very often a response coming back saying 404. Yeah, what that meant is object not found. The web page is not found. So 404, that status comes with a meaning. Okay, so we define also the semantic of some of these code words. Now, this is really nice to send code words because you use few number of bits instead of sending longer English strings. Okay, so meaning of the information in the fields. Now, of course, right, this is almost like defining a language. Yeah, the rules, the timing we send the message, and when we receive a message, what kind of message we generate next. Okay, so all four together, the types, the syntax, the semantics, and the rules of corresponding back and forth between the processes. That's called the application layer protocol. So each application defines its own application layer protocol, defining the messages it requires and the syntax, semantics, and the rules of exchanging the messages. Now, many of these application layer protocols are open, meaning if you just Google, you identify, for example, the World Wide Web's application layer protocol. That is actually called HTTP, and it's defined in one of these RFC documents. So these protocols are open such that if I want to come up with my own browser, because I know, hey, HTTP request, what the format should be like, the syntax, semantics, and rules, then I can write a browser such that it behaves just like the other browsers following the same RFC document. Same for email. Okay, so these open protocols are nice out there because each one of us can develop independently a new web browser, a new email reader, a new web server, a new email server. Now, many of the applications are commercial, owned by companies. So they do have their protocols, but they are not open. So these are the proprietary protocols. For example, Skype, we talked about using the hybrid model to communicate. It's got its own set of messages and syntax and semantics, but they are closed. It's hard to come up with our own client, Skype client, such that it works with the legit Skype clients. So that was application layer protocol. So it turned out that those protocols are to define the message formats and etc. Now, the last design component is actually probably just as important as defining the architecture. Okay, it's called how do we decide what transport layer protocol we use to support the application. Now, before we can choose, let's talk about quality of service. Now, in order to know what is the right transport layer service for an application, we need to think a little bit more about the application we're designing. What is the nature of the content we're sending, and what the users might be expecting. The first criteria is called the data integrity. This concerns whether the data needs to arrive without any loss. The key word here is that if the apps are about sending text-based content, for example, a file, for example, a web page, for example, a text message, then users are expecting 100% reliability. If we are sending audio video, it's okay to have some loss. Think about speaking a sentence. If we miss a syllabus here or there, the listeners being human beings, we are intelligent. We can still make up the full sentences or make up for what the speakers want to say by looking at the context before and after the sentence. Second criteria, growingly important, timing. This is especially the case for interactive applications. So the key word here is interactive. Internet calls, live video sessions, or shooting games, interactive games. Users are indeed expecting low delay. Okay, and you guys know. Third is throughput. Okay, this is sometimes referred to as bandwidth requirement. Nowadays, we send multimedia content, audio, video. Text-based content, it does not require too many bits to send them, so it's not an issue. But for video and audio, we do need a substantial amount of bits per second in order to deliver them, so that the bits after recovery, is in good quality. So if you compare video versus audio, the throughput requirement for video is higher and audio lower. Text, much lower. So we need to somehow guarantee a minimum amount of bandwidth in order for these audio-video communication to be effective. Text-based applications are elastic apps because there's no strict bandwidth requirement. The requirement is elastic. Fourth criteria, security. This is probably nowadays the most important criteria. Are the users expecting we are sending data such that we are protecting their privacy? Okay. So these four criteria together, we actually give it a special term. They are also called the quality of service. So before we can define what transport layer protocol we use, we need to think through what kind of quality we will be providing the application service. Let's go over a few common applications and see if we could sort out their quality of service requirements, or in short, QoS requirements. First application, file transfer. Transferring files are static objects, most of them text-based. Therefore, in terms of data integrity, we demand 100% reliability. File transfers, we do not expect they arrive in a few seconds. Okay, so it's not delay sensitive. As a result, there's no strict bandwidth requirement. Therefore, the throughput part of the QoS, elastic. You can probably imagine email and web objects. These are transferring also files, email files, transferring web pages, web page files. Therefore, the QoS requirements very similar. The second application here is real-time audio video. So, first of all, the nature of content, audio video, different from text. Therefore, keyword, non-text, it can be delay tolerant. Another is it's real-time, that means it's interactive. That's another keyword, which means we do have delay requirement. And for real-time, that's showing the audio, video that's happening right now. So the delay needs to be less than hundreds of milliseconds. So you feel like it's happening right now. Audio, video, now there's time sensitivity, therefore we need to maintain minimum bandwidth. So there's a bandwidth requirement. And the requirement for audio, lower, video, higher. These days, some users might actually expect even higher bandwidth for video. Now, can you think and push a little bit and see if you know the QoS requirement for stored audio video? Well, first of all, keyword, audio, video, non-text, therefore, you can probably guess data loss here is loss tolerant. What about the delay requirement for stored audio video? It should still be some requirement, but probably not as strict as the real-time audio video. And you're right. Delay can be a little bit longer. But given that there's delay requirement, the throughput is still hard. We still need to make sure that there's a minimum amount of bandwidth available. And audio video, the bandwidth requirements are because of the nature of the content. So it will be the same. Audio, 5 kilobits per second to a megabits per second. Video, 10 kilobits per second to 5 megabits per second. Now what about this one? Yeah, interactive. The keyword is similar to the real-time nature of this application, isn't it? Except that this is now game data. So you can imagine, oh, delay requirement here, just as strict as real-time audio video. Is it loss tolerant? It's a little bit tricky, isn't it? What about throughput? If there's delay requirement, then there's usually a throughput requirement, but it should not be as high as video or even audio. So here, just a few kilobits per second. Game, this part is debatable. For some games, for example, shooting game, some of the players would argue, I want no packet loss. Okay. But for most of the interactive games, it's okay to have some loss. Okay. And then the users, the players, can try to repeat actions to make it up. What about text messaging? Keyword text, so no loss, obviously. Throughput? Yeah, it depends a little bit on the delay sensitivity, isn't it? And text messaging these days, yeah, it's also debatable whether it's time sensitive. Some would say yes, some would say no. Okay. But you see also that the delay we experience in text messaging, most of them are probably thinking delay, not network delay. Okay. All right, so far so good. But even though that we know there are these QoS requirements, and you probably know now what the QoS requirements are for the application you want to develop, you still cannot decide what transport layers to choose because we don't know what the options are. So here comes the options. In order to find out what is the right transport layer protocol for an application, we also need to know what the options are. We do have two. TCP and UDP. TCP is the one more elaborated. UDP is very primitive. Let's focus on TCP here. The reason it's more elaborated is because it provides reliable transport. Think, a sending process and the receiving process. If we connect the two of them using a TCP at transport layer, data will always come to the receiver 100% correct. There's not going to be error. There's not going to be lost packets. How do we do that? Well, let's talk about that in Chapter 3. In fact, that's the main content in Chapter 3. For now, keep in mind, TCP provides reliable transport, no data loss. Second, TCP also does flow control between sending process and receiving process. The sending process here is checking whether the receiving process is busy or not. In case it's busy, the buffer gets full because data comes to the receiver and gets buffered temporarily here. if the receiving process is a little bit busy, the speed that we extract the data out to the application could be slow, so buffer builds up. If the sending process is sending data too fast, those data arriving to a full queue, full buffer, data get lost. If TCP is doing all it can to try to recover from loss, it doesn't make sense that sending process is sending data too fast to create data loss. So, flow control, some sort of communication going on between the receiving process and the sending process so that the sending process will slow down. Congestion control. It's a little bit similar to flow control, but it's between all these other routers in the middle of the path from the sending process to the receiving process. In case any of the buffers, in the middle on the internet is close to full, sending process slows down. If the buffer is no longer full, packets can go smoothly, speed also comes back up. So that is called congestion control in TCP. This, in fact, is also one of the main content that we'll talk about in Chapter 3. So for now, just keep in mind, TCP does reliable transport, flow control, congestion control. TCP, however, does not do this. Timing guarantee, minimum throughput guarantee, security guarantee. So the other three QoS requirements we talked about, TCP does not provide. The only QoS guarantee it provides is reliable transport. So this is TCP. Now there's one more feature about TCP. It's called connection oriented. To set up a TCP connection at the transport layer, the sender and receiving process also do some sort of control message exchange to set up a connection. So this part of internet, although it's a packet switching network, but the behavior is a little bit like the circuit switch network. And there's a reason for it. This is so that we have more communication so we could recover from errors. UDP, it does not do reliable data transfer. There's nothing really going, no more communication between the sending process and the receiving process. Sending process just send, receiving process just receive. It does not provide flow control, congestion control, none of these timing, throughput, security guarantee either. There's no connection set up. So this is really the native packet switching network transport layer service model. Now you know, TCP essentially does nothing. You're right. The question is, why do we bother having UDP? Why don't we just use TCP? Yes, if you recall, among all these applications we've mentioned, text-based content, we prefer reliable transport. But is there other kind of content that reliability is not necessary? It's okay to have some loss. Yes. Sending audio video is not necessary to have 100% reliability. So quite a few of these audio video multimedia services, multimedia applications, prefer using UDP as the transport layer service. Here, let's go over some common applications and see what transport layer protocol they pick. Email, well, in fact, remote terminal access, remote logging, such as the terminal you're using to remote logging SSH to the PA server. Web downloads, file transfer, all these are what? Text-based, static objects. Reliability important, but it's elastic, no delay requirement. So, not surprising, you see them all using TCP. So these are just the specific protocol, each of the application is using. Email is the application. The application layer protocol is called SMTP, Simple Mail Transport Protocol. For World Wide Web, this is the application. The protocol supporting World Wide Web is HTTP. File transfer, the protocol, FTP, standing for File Transfer Protocol. Now, these two other applications, streaming multimedia such as Netflix or YouTube Live, audio, video, reliability is no longer required. Therefore, you see, some streaming multimedia applications use UDP, but some stick to TCP. Internet telephony, Google Meet that we're using also on the side is one such internet telephony application. It's audio video as well. So UDP, and sometimes some of these internet call services are TCP. And that takes us to the quiz today. So this is quiz number 7. So you just saw a few examples. For text-based, you choose TCP. For audio-video, there's one more option. You could use UDP, but you can also still use TCP. Now, what about games? Okay, it's not text-based, exactly. It's not audio-video, exactly. It is interactive. Okay, so there are 3 games here. Polly is listing. On the left is the Farmville, so you grow vegetables, and as time goes, the flowers or the carrots or cabbages will grow. Yeah, so your friends might come over to steal some of these vegetables from you, but you can also sneak into their garden and steal their flowers, their grows. Okay, so Farmville. For this type of game, do you think that there's delay requirement? Do you think that there's throughput requirement? Do you think that there's a no loss requirement? Now, if you think one way or another, which transport layer protocol would you pick? Similarly, for PUBG, the middle picture, that's a first-person shooting game. Okay, so you can probably imagine having more strict delay requirement here, right? Do you think that the users would demand no loss requirement as well? Okay, so what do you think? PUBG, if you're implementing a game like this, would you use TCP or UDP? So tell why as well. Last one is a role-playing game. It's called RO. Okay, and I think the gameplay is a little bit like a Maple Story, except the Maple Story is only 2-dimensional. I think RO is 3-dimensional, looks a little bit more complicated. So a role-playing game. In a role-playing game, you can simply chat, trade, virtual treasure. You can also be owls, hunting monsters. You can be in a group, trying to complete the raid. So there are multiple gameplays inside a online game like RO, a role-playing game in particular. So for this type of game, would you use UDP, TCP? Okay, and for any of the game, maybe you would consider using both, like a hybrid model. For some part of the gameplay, TCP, some other parts of the gameplay, UDP. Okay, so this is a long quiz. You guys might want to think it through, so we'll be given time. So find your teammates and let's start. Yeah, so that's kind of a thinking music. This is the theme song of a game show called Jeopardy. It's a IQ or knowledge type of game show. Yeah. So I put you in the mood of thinking, what should be the right answer for it? I think that's enough thinking time, and I'm seeing that some of the teams have already typed up solutions. So why don't we go through the early solutions while the other teams are working? I know some of you guys often have split opinions, split answers. It's okay. You can type up, each one of you's opinions, so it's okay. So let's see. Team 2. So Yunqi is speaking on behalf of Team 2. It depends on the genre of the game. It is indeed, isn't it? Of course, general principle is that if it's required that there's no data loss, definitely TCP. But otherwise, if there's particularly delay requirement, then UDP. Okay, very good. So Team 2, you guys come up with a very general principle. For RO, so I guess what you meant by the first statement here is Farmville, there's no delay requirement, but maybe you care whether if you steal the cabbage of your friend, you want it to be complete, right? So maybe for Farmville, you would take TCP. For shooting game, there's delay requirement. Maybe you pick UDP. RO, it's complicated because everyone like it and it's a perfect game. And there's a monster named Poly, which sounds like Polly. Oh, it is, isn't it? Well, actually, Poly is a very popular monster name. Yeah, so maybe for RO, some part of the gameplay, because there's short delay requirement when you are raiding a huge boss, right? You don't really like to have delay, and you probably cannot bear losses either. But if delay is given a higher weight, then you use UDP, right? If loss is a higher weight, TCP. But what I do usually, based on my experience playing MapleStory, I just hit the monster continuously. So in case one of the hit is lost, even if if I'm using UDP, it should be okay because there'll be more hits coming next. Okay, so can be a little bit tricky, isn't it? So Yunqi here, I like that you give the general principle. Boris here, Farmville. UDP because it doesn't seem to require high-speed transmission of information and data. What is the advantage of UDP? Simple, maybe. Yanjun. Farmville UDP, because it doesn't, Farmville seems to be a harmless little game. Nothing is really critical. Sure. PUBG and RO TCP, these are action games. Instantaneous data to be correctly transferred. So you use TCP and hope that beside being 100% reliable, the data also arrive with short delay. You don't want your HP to be falsely computed. Definitely, right? So reliability is indeed important, especially when you are playing with the big boss. Okay. My O have a mixture of UDP and TCP, of course. Very likely. Such as what, let me roll back in the YouTube chat. Right? Lawrence was asking, can you have UDP and TCP at the same time? In fact, you can start two connections connecting the same pair of processes. And but you might need to have another port there to separate the two flows. So sometimes you see a process associated with multiple flows. But it might get a little bit tricky if you use one process to associate with 2 port numbers. Okay, but in practice, it's possible to program such a pair of processes. Okay, so yeah, you could use TCP and UDP interleavingly as well as simultaneously. So some game messages you can send through TCP, and some game messages probably UDP. I think you guys are picking it up, indeed, right? You would think that sometimes you want this data being TCP. For example, if you're doing trade in the market, playing RO or MapleStory, can it be lossy? No, probably not, right? You probably play a large sum of game money, and yet you didn't get the treasure you want. Ouch. So, Yuxiang Team 1, Farmville, since it is not a real game. Okay. Sorry to hear that. Farmville designers will be sad. PUBG RO needs small delay, UDP. Okay, that's a good point. Though I said that PUBG use UDP, but shooting game like this needs reliable data transfer. So I use both TCP and UDP. So perhaps you use TCP first. In case the delay is too long to be bearable, you switch to UDP. How about that? All right. PUBG cosplaying with friends is really interesting. Okay. So you obviously like PUBG better than Farmville. Okay, Ida, Team 10. I guess you'll be typing up the rest of the story. Team 7, Jieming. PUBG UDP, but RO and Farmville TCP. Yeah, I can see that PUBG, delay is very, very sensitive. It needs to be faster than human reflexive, right? Otherwise, you shoot really fast, but the network delay too long. Ouch. Okay, you lose because you don't have good network, not because you don't have good skills. That's not fair. I think a lot of time, Jieming and Team 7, you got it right. Being fair is more important playing a game. Mindy for Team 3, Farmville, TCP. Okay, doesn't need instantaneous response. Yeah. Okay, that makes sense. And I guess Mindy takes Farmville seriously. Obviously more serious than Yuxiang. It's not a game, really. PUBG UDP, instant replies. Very important, isn't it? RO hybrid, for trades, TCP obviously. Playing raid, UDP. But, casually hitting poly, because I think poly is usually the entry-level monster, so it's probably okay. to miss a couple hits. So UDP might still be okay. Yo Team 4, Farmville TCP, PUBG UDP, RO UDP. If we use TCP for RO and PUBG when there is a transport congestion, yeah, it is. Okay. Until the data transfer, it's good for the game like this. Yeah, so UDP is generally better for not just audio, video, but interactive data, interactive text as well. But you see, when I was saying that audio video does not require reliable transfer, and therefore we prefer UDP. But sometimes you do really like to have a viewing quality, perfect viewing quality, or perfect acoustic quality. So if, in case you're streaming off KKBox, okay, you want the audio quality to be good. Yeah, sometimes you would think that TCP is necessary when you hear, for example, classic music. Yu Hao. Oh no, that was Team 14 from Yu Hao, was it? Okay, so you guys are typing things up. I actually lost track of you. Okay, but hey, generally you guys get the idea. Okay, when you are designing an application, not only you design whether you want it to be simple client server or you want it to be fully distributed, peer-to-peer, okay, everyone plays the same role, everyone equal. Or you want your application partly peer-to-peer and partly client server. So deciding the communication model. You also need to define the message formats. You also need to decide what default port number to connect to the server. Okay, or between the peers. You also need to decide what transport layer protocol you use. And which one exactly you use depends on the nature of the application, and also depends on what your users might be expecting. To what level users you want to attract. Okay. All right, so let's not go any further. All right. So I see that you guys like the Jeopardy theme song. Yeah, because it gives you to this relaxed mode so you can think and brainstorm with the team members. And by the way, this is still copyright song, but I figured out the way to remove copyright later after the live broadcast. The only trade-off is that if I do the editing of the live lecture session, the chat goes away, so you cannot replay the chat. Okay, so what I do is that I take photos of the chat, okay, so that I can track the participation. After that, then I edit the live lecture video. The reason that I learned about the trade-off is that I edited the episode 5 where I played the Harry Potter theme song at the beginning to get you guys into the mood to focus on the lesson. I discovered that I lost the chat, and so I couldn't track participation for that week. Please, sorry about that. Okay, but please, it's okay. It should be okay because we just lose 1 week. Okay, and by the way, if you go to the shared Google form to track the course progress in terms of grades, you'll also see that for participation in each category, I limit the maximum number of points you earn in each category each week. Okay, so I will count it to 5 and stop there. All right. So that should give each of you some chance to, for example, speak on YouTube chat or type up things on Slack or join the Google Meet session. And you see also that some students asked to go on the office hour. Okay. So for the early comers, I give extra points. So you're encouraged to use also the office hour, which is coming Thursday, lunch hour. Okay, good. And hey, make sure that you start PA3 a little bit earlier than possible. And let me see if there are more questions here. I think Yan Jun is saying that, is there an advantage of using UDP? Yeah, economical or something like that. A lot of time what people do is that they use UDP and they come up with their own mechanism to do data recovery, to do data transmission control. Instead of having the transport layer protocols doing it, they add some more mechanism at the application level. Is UDP some more time efficient and cheaper than? It is, Jiawen, indeed. Yuxiang, I meant farm is not real. Oh, okay. Okay, sorry. Yuxiang, I'm mistaken. Okay, so Farmville. Oh, lots of respect to Farmville from Yuxiang. It's just that it's not a real-time game. All right. Sorry about that. Wait. Which one? Which protocol is like to use in general? Okay. Jiao is asking a bigger question, right? For the games we have now, which protocol is used more? I think TCP. There's a good reason for it because many of the firewalls people set up, one of the default in the firewall is blocking all UDP. That is why Skype, for example, it's an audio-video application. A lot of the real Skype calls are running under TCP because they find very often some peer the caller is calling to, they run a firewall and UDP are entirely blocked. Okay, but this is not really the UDP's fault. It's because UDP seems to be an option nowadays for firewalls to when you're setting up a firewall, it's a default option, blocking UDP. Is there any, so Yunqi was asking, is there any relation between TCP and UDP's name and their properties? Very good question, Yunqi. You know what? Internet engineers actually come up with these names a little bit randomly. So TCP is transport control protocol, something like that. UDP is I actually don't remember. I know D is Datagram. Okay, I forgot exactly what you meant. Okay, if you recall, packet switch network is also called a datagram network. So UDP is actually the native transport form for a packet switch network. Okay? But it's until later. So UDP is the protocol that's designed first. Well, actually, it doesn't require design, in fact. It's the first protocol implemented, primitive, straightforward. But later on, we do see we need reliability sending emails. Email is, in fact, the first application. And so we need to do some sort of recovery. Okay? Therefore, we have the TCP. What I meant is that why they are naming that way. Sorry about that. There's no reason. Why is poly? Yeah, because my parents feel like naming me Polly. Yeah. Boris, I wonder, since UDP seems not to guarantee data transfer and audio may use UDP, how can we have the sound music we human understand? Yeah, so Boris, that's a very good question. If you have a really good compression mechanism that can somehow recover from bit losses, bit errors at the receiving end, it's probably very okay to use UDP. But if the compression mechanism is not that good, it might be better to use TCP such that it's lossless. So for audio video, there's this compression mechanism as well. We'll talk about audio video with more detail in 2.6, chapter 2 as well. Oh, okay, user datagram protocol. Thank you for looking it up. Why does firewall block UDP? Very good question there. But let me come to Bo-zhi's question. If an online game is using UDP and data loss happened, how to deal with the data loss condition? Okay, Bo-zhi, you're asking exactly what we will talk about in chapter 3. The general technique is to try to to detect loss first and then retransmit. Okay, there's another way, which is to send redundant data. So send multiple copies of it. Hope that one of the copies get through. Okay, so there are actually options. But you get the general idea. Two big flavors. Detect loss, retransmit. Or you send redundant copies and hope that at least one of the copy get through. But you can see a trade-off between the two, right? The first one, to detect and retransmit, it will consume less network bandwidth, okay? But the second one, you send multiple copies at the beginning, but the network might be fine, right? But sending multiple copies consume more bandwidth already. But in the second case, you don't need to detect there's a loss. Delay is lower between sending and receiving a good copy. Yuting asks, why firewall block UT? Because we have so many hackers and they are getting really good. If they send a UDP stream to a server and having many bots sending UDP traffic, because UDP does not control the sending speed. So the hacker can actually sending really high bit rate and all going to the server. The hackers can quickly bring down services on the internet. Same to your home network, access network. It might just kill all the downlink bandwidth you have. Yeah, so good. Thank you, Boris, for filling me in. UDP is user datagram protocol and TCP is transmission control protocol. Okay. Yunqi, there are no reasons. I can't think of reasons for them. Okay. All right, good. Thanks for sticking around, and that's all for today. Tomorrow, we'll actually talk about there's transport layer service for the fourth QoS requirement, security. Okay, I'll see you tomorrow. Tune in early, otherwise you'll miss that part. And before I close the session, I need to record what we have on the chat. And guys, go to the next lecture. Okay, good. So let me close the session here.